Let's explore how to solve this polynomial question from the Amc 10A. Let p of x be the unique polynomial of minimal degree. P of x has leading coefficient 1. 1 is the root of p of x minus 1. Basically, what this means is that p of 1 minus 1 is 0. Because 1 is the root of p of x minus 1. So when you plug in 1 over here, it becomes 0. This is also equivalent to p of 1 is 1. 2 is the root of p of x minus 2. So what this is saying is p of 2 minus 2 is 0. Because you plug in 2, it becomes 0. Or p of 0 is 0. 3 is the root of p of 3x. So you say p of 3x. The root is 3. So you plug in 3, you get p of 9, which has to be 0. Because 3 is the root of p of 3 of x. 4 is the root of 4 times p of x. P of 4 times p of 4 has to be 0, i.e. p of 4 is 0. So now it's a matter of looking at the roots of the polynomial and using the polynomial representation, the one in terms of roots, not coefficients. So leading coefficient is 1. That's nice. We don't have to, you know how the expansion is a times x minus root 1, x minus root 2, so on. That a is just 1 in this case. So basically our polynomial is just x minus all the roots multiplied. So what are the roots we know? Well, we know 0 is a root, 4 is a root, and 9 is a root. So we can just say x, because x minus 0, and then x minus 9, and then x minus 4. And then there could be other roots we don't know. Okay, so that's what these three conditions give us. That this is going to be a part of our polynomial. Now what about this one? P of 1 equals 1. So this leading coefficient is 1. So there could be some more roots here we don't know about. So let's just plug in 1 into this polynomial, because we know that when we plug in 1 as x into this, it has to be equal to 1. So we get 1 times negative 8 times negative 3. And then it says minimal degree here. So the first thing is, okay, is it possible for it just to be cubic? Just have these three roots. But if you evaluate this expression, you see it's 24 and not 1. So a cubic is not possible. Just these three roots is not enough because it gives a value of 24 for p of 1, not 1. But the question is, can we maybe do a quartic for the fourth degree polynomial? And the answer is yes, we can do a quartic. Why? Because let's say this is x minus r. So over here it becomes 1 minus r. We can pick this root to be whatever we want such that this becomes a quartic. This whole part over here is 24. And we have that this part over the second part, x minus r, therefore has to be 1 over 24 in order for this whole thing to be equal to 1. So r is 23 over 24. And that root that's not an integer is 23 over 24, which has a sum. Add these two, you get 47, which is the answer. So the key idea here, which is realizing what each of these conditions mean, and realizing that that means 3 of these are roots. And then from there, we just plug in 1 into this whole expression, and then we find out that, okay, cubic is not possible, but quartic is possible, because when we add this x minus r term, then we can solve for r and see that, okay, yeah, if r is 23 over 24, then this quartic has p of 1 equals 1. And therefore we get our answer. Thanks for watching.